So today we are going to be starting with AS level chemistry, chemical bonding. So let's get started with this topic. This is a very important topic. Majority of your paper is based on chemical bonding. In 2025 as well, the majority paper came from chemical bonding, and moreover, it's a bridge between your O levels and A levels. So let's get started with the questions. These are going to be the latest questions that we guys are going to be practicing. So let's get started. Arsenic forms a compound with fluorine. In this compound, both the arsenic atom has no lone pair. Okay, there's going to be no lone pair with arsenic, and there are no dative bonds. That means that arsenic is all the valence electrons in arsenic are bonded with fluorine. So let's check out how many valence electrons arsenic has. Arsenic is basically a group 15 element. It's a group 15 element, which means it's going to have 5 electrons in its last shell. And since it has 5 electrons and all electrons are going to be involved in bonding with our fluorine, since we have heard that there are going to be no lone pair, so the formula is going to be AsF5, because fluorine only makes a single bond. Fluorine is in group 17, it's going to make a single bond, and arsenic is in group 15. Ideally, in order to get a stable electronic configuration, you might think that arsenic wants a stable electronic configuration. So if this is arsenic, it should make 3 bonds, because it already has 1 2 3 4 like this. So you might think that it should make bonds with fluorine like this. This is one fluorine, this is second fluorine, and this is third fluorine. And if it does this, it's gonna obtain a 8 electrons. That's right, and I agree with you guys. But right over here, if we do this and try to fulfill the octet, what's going to happen is that there's going to be a lone pair with arsenic, which we cannot have, because the question clearly states that arsenic has no lone pair. So if you try to fill the valencies and complete the octet, you're going to end up having lone pair. So you have to bond all the electrons with fluorines. So it's going to be AsF5. Selenium also forms a compound with fluorine. Okay, there's going to be a compound of selenium with fluorine. In this compound, selenium atom is no lone pair. There has to be no lone pair with the selenium atom, and there are no dative bonds. Okay, so let's check out which group selenium belongs to. This is selenium. Selenium belongs to group 16. Selenium is a group 16 element. So since selenium is in group 16, this is what selenium might look like, and it's a group 16 element, so it's going to have 6 electrons in its valence shell, and all electrons are going to be involved in bonding with fluorine. So it's going to be, what's going to be the chemical formula of selenium? It's going to be selenium fluoride, SeF6. Why SeF6? Because all electrons have to be involved in bonding, no dative bonds, and no lone pairs. Otherwise, if you were trying to fulfill the valency, it would be SeF2. But no, we're not trying to fulfill the octet or the duplet. We are only concerned with what the question says. So don't be confused. In which compounds are there 2 different bond angles? We have to find 2 different bond angles. In this question, 180 bond angles must be ignored. Okay, so first we are looking at a trigonal bipyramidal compound. So first let's think about AsF5. So we have 5 bond pairs. Let's draw them and see what's going to happen. So this is As and F5. So it's going to be something like a trigonal bipyramidal. So we have to draw it. First, they're going to be 180-degree bond angles, like 120 degree. These are all 3 120 degrees apart, and then there are going to be 2 bond angles like above and below, something it's difficult to show you guys this thing in 2 dimensions, like this and this, and these 2 are going to make an angle of 90 degree. So it's going to be something like, you can imagine 2 pyramids, one on top and one on bottom. It's going to be trigonal bipyramidal. So there's going to be angle of 120 and 90. So it has 2 angles, 120 and 90. And the third angle is 180. And 180 angle is between what? 180 angle is between these 2 flat lines like this. So trigonal bipyramidal with 2 angles, AsF5 have 2 angles which are 180, not 180, three angles almost, like 180 is obviously there. Then there is a 90 angle, and then there is a 120 degrees angle. And SCF6 selenium fluoride, how many angles it has? It has two types of angles, 180 and 90 degrees. So let's check out selenium fluoride. How is it going to be like? There's going to be a selenium atom, and then there are going to be 6 fluorines like this. Above, below, like this, all are 90. All angles are 90 in 3 dimensions. Right now over here it might not seem that they're 90, but they're all 90. It's like flat this, and flat this. Just imagine the structure over here is selenium. Imagine it in 3D. So they're going to be all 90, and these two are going to be 180 degrees, and these two are going to be 180, and these two are going to be 180. Otherwise they're all going to be 90 degrees. So selenium fluoride is going to have angle of 180 degrees for sure and 90 degrees. What the question states is that which compounds they have bond angles, two different bond angles. So we are going to have two different. This has two different if we ignore 180. So arsenic fluoride only has two different bond angles. Moving on to this question. The structure of sulfur dioxide molecule is shown. Okay, so it's good that we're shown with all the lone pairs and everything. That's good. What is the shape of sulfur dioxide molecule? Okay, to confuse you guys, they've drawn it like in a flat line so that you might think that this is a linear molecule, but this is not linear. This is only there to confuse you. This is a bent molecule. Why this is a bent? You look at this lone pair on top. This is going to apply pressure on these two. This is going to bend these two down like this. So it's going to be a bent shape molecule. This lone pair is going to force these bond pairs downwards. So it cannot be linear, it cannot be pyramidal. For pyramidal, it has to have 3 bond pairs and 1 lone pair. For tetrahedral, it needs to have 4 bond pairs. So definitely it's going to be a non-linear molecule. Moving on to the next question. When solid aluminum chloride is heated, Al2Cl6 is formed. Which bonding is present in Al2Cl6? That's so simple that you just need to draw it, and even if you don't draw it, you should learn this. You have aluminum, you have 3 covalently bonded, simple covalently bonded chlorines to it. Then you have another aluminum. Let's make the 2 aluminums like this, which again has 3 covalently bonded chlorines like this. And then there is a dative bond. A dative bond which is made, let's move this a little downwards like this. And the dative bond is that this chlorine is going to share its lone pair over here, and this chlorine is going to share its lone pair here. So now we have a perfect molecule, Al2Cl6, and this is a dimer because it's made from 2 normal molecules like AlCl3 plus AlCl3, which forms a dimer Al2Cl6. So it has 1, 2, 3, 4, 5, 6 covalent bonds and 2 dative bonds. So there's going to be a covalent bonding and coordinate bonding as well. Coordinate is a simple word for dative bonding. Moving on. The table shows physical properties of 4 substances, W, X, Y, and Z. Okay, good enough. Melting point of W is this, boiling point is this, electrical conductivity of solid is poor. Okay, when we hear that electrical conductivity of solid is poor, so we come to know this is not a metal. This is not a metal. This has to be a ionic compound or covalent compound. Ionic compound or covalent. Okay, electrical conductivity of liquid is good, definitely ionic. Electrical conductivity in water is good, definitely ionic. So for W, I'll choose anything that's ionic. Magnesium oxide, ionic, this ionic, this ionic, this ionic, all 4 are ionic. Moving on to my second, which is X. X is firstly melting at this point, which tells me it might be a simple molecular substance. Then it has a boiling point of 39, which is like above room temperature. It gets little above room temperature. Electrical conductivity of solid. Electrical conductivity of solid is poor. Electrical conductivity of liquid is also poor, and it's insoluble. Okay, let's check. It can definitely not be HCl, because HCl has excellent electrical conductivity in water. In aqueous, it's highly soluble gas. This HCl, this is a highly soluble gas, and you remember, it dissolves in water to form your very own very favorite hydrochloric acid. So it cannot be HCl if it's insoluble. HCl has highly soluble. It's a highly polar molecule. The bonded electrons, they're being continuously being attracted towards this chlorine, which has a partial negative charge. This has a partial positive charge, and this bond pairs towards the chlorine. So this is a polar molecule that's going to instantly dissolve in water. This bond is going to break, hydrogen is going to be separated, releasing H plus signs, making the solution acidic. So this has to be this thing, CH2Br5, this. Okay, why is, firstly, its melting point is this, definitely a transition element, because it has a very high melting point. Boiling point also very high. Transition element. Conductivity of solid, good. That means metal. Transition element, I'm thinking about electrical, good. And it's insoluble in water. That means it does not react with water. Definitely not potassium. Potassium is extremely reactive. It reacts like nothing else with water. It reacts vigorously with water, and definitely this high melting point cannot be of potassium, so it's going to be iron. Okay, now Z says that it melts at this, boils at this. Electrical conductivity of solid is poor. Okay, solid, it's poor. Liquid is poor, and it's insoluble. Al2O3 is soluble. You should remember that this is a highly soluble molecule. How do you know it's soluble? You read this reaction when doing periodicity. In periodicity, you read the reaction that Al2O3, it basically dissolves in water. Aluminum oxide is soluble. So it's going to be option number C. Consider the following 4 compounds in which what is the order of increasing boiling point of the compounds lowest first. Okay, so we have to discuss the order of the boiling points, the lowest first. Okay, firstly, what do I see? I see a hydrogen bond here. Okay, then this one is a branched molecule. This one's gonna have branching, so definitely that's gonna decrease. All have the similar amount of carbons, I guess. Yeah, they all have similar. This one has a lower amount. It has 3 carbons. It has this SH part that's gonna make it polar. If the S is bonded to H, then it's gonna be a little polar. So definitely the highest 2 is gonna have. So at the end it should be 2. And the lowest, 1 and 4. What's going to have the lowest? Definitely 1 is going to have the lowest. Why 1 is going to have the lowest, not 4? Because look, 1 is a branched molecule, and when you're branching, your melting point decreases. Because of branching, your melting point decreases. 1 is something like this. There is a branching in 1. So the melting point is going to decrease, because when you are unbranched, the molecules lie closer together. The van der Waals are stronger, and when you are branched, the van der Waals are weaker. Because branching, if this is a branched, what happens is that your area of contact with the other molecule decreases. And when you are flat like this, your area of contact with the molecule increases. So I guess this is going to be the correct one. Which shape is correctly predicted by the Vesper theory? Number of bonded electron pairs 2, number of lone pairs 2. It's going to be linear. No. We are talking about water here. Water has 2 bonded pairs, 2 lone pairs. The shape is definitely going to be non-linear. Okay, next says number of bonded electron pairs 2, lone pairs 2, tetrahedral. No, that's going to be non-linear. Tetrahedral is going to be there 4 bonded pairs and 0 lone pairs. So definitely not this. Okay, yeah, that's correct. If you have three bonded pairs, three electron bonded pairs, and one lone pair, that's gonna be a pyramidal. And for trigonal planar, you should have only three bonded pairs, no lone pair. Then you're gonna have a planar molecule. So done with this. In which pair are both species free radicals? Free radicals are not part of this right now. A structure of borazole is shown. Okay, this one right here, this is a borazole molecule. Which shape is borazole and how many pi electrons are there in the structure? The shape, either it's going to be non-planar or it's going to be planar. Acha, one thing you guys should agree that when an atom forms just three bonds with no lone pairs, three bond pairs and zero lone pairs, what shape is this? What shape is going to form when you have three bond pairs and zero lone pairs? You should agree that this is a trigonal planar shape, and this is going to be a planar. So now I'm going to prove you that there are three bond pairs and zero lone pairs in all the central atoms. Okay, boron is in group 5. It's in group 5 or 3. A second, let's check. We have the product table. Boron is in group 3, right? So it has 3 electrons in its valence shell, and since it has gained this 1 electron, it means it has 4 electrons. So 4 bonds, 1 2 3 4 bonds, no lone pair. And when we have double, single, triple bond, we consider it one bond, while in the VSEPR theory we consider it as a single unit. So there's going to be 3 bond pairs around it, 0 lone pairs, angle is going to be 120 degrees, and this is going to be trigonal planar. Now we're going to discuss for all. Boron, done, trigonal planar. Now nitrogen. Now, how many electrons nitrogen has in its valence shells? 5. Nitrogen is in group 15. Check it for yourself. Group 15, 5. Now, how many bonds is it making? 1, 2, 3, 4 bonds making. This means there's a 5th electron. Since it's a positively charged, this means it has lost this 1 electron. It only has these 4 electrons. And since double, triple, single, all considered single, angle 120, and this is again a trigonal planar molecule. Again a trigonal planar molecule. Check for all borons, all nitrogens, all are going to be trigonal planar. Number of pi electrons. These are double bonds are this second bond, this one's a pi bond. Pi bond formed between unhybridized p orbitals. Okay, so 2 electrons on this bond, 2 electrons on this bond, and 2 electrons on this bond. How many pi electrons we have in total? 1, 2, 3, 4, 5, 6 pi electrons we have, and it's a planar geometry. So it's going to be option number D. In which species does the underlined atom have an incomplete outer shell? Obviously BF3. BF3 has 6 electrons. Boron has 6. Boron needs 8. So it's going to be A. I just see it and I know it. How? Because look, this is your very nice boron, and unfortunately it has 1, 2, 3, and now it makes bond with 3 fluorines, 1, 2, and 3. So 3 fluorines. The problem is this is a single bond. Since all bonds are single, Abibi, the octet for boron is not fulfilled. Check it for yourself. Boron unfortunately has only 6 electrons in its outer shell, and how many boron needs? It needs 8 electrons. It has 6 electrons. Check for CH3 negative. Obviously it's gonna have 8. How it's gonna have 8? Because 1 carbon, how many electrons it has? 4. 1, 2, 3, 4. It has gained, how many? It has gained 1. 1 it has gained because it's a CH3 negative. And how many hydrogens it has? 1, 2, and 3 hydrogens. Now count it for yourself that this is a full octet. Check for F2O as well, full octet. Obviously, full octet, one oxygen. How many it needs? Two electrons more. So there's going to be two fluorine making a single bond with it. Acha, H3O plus, similar situation. There's going to be a dative bond between one hydrogen and oxygen, but the octet is going to be full. Ammonium ion, NH4 plus, there's going to be a dative bond. How is it made? Just check out. You have this, you have H, H, and H, and one dative bond made with this H plus. This entire thing, it has a +1 charge on it because this hydrogen has one less electron. It only had one electron, which was unfortunately taken away by some other atom, and now it has no electrons. Okay, the which statement about the changes that occur in this reaction is correct? The dipole moment of an ammonium ion is greater than the dipole moment of an ammonia molecule. Okay, so the dipole moment of an ammonium ion, it's greater than the dipole moment of an ammonia molecule. You should realize this thing that ammonium ion, the dipoles cancel out because it's a symmetrical molecule and it has same ligands. Ligands are these attached atoms. It has same ligands. Symmetrical molecule dipoles cancel out. So ammonium ion has a lesser dipole. Ammonia is going to have a lot of dipole because in ammonia, this is N, this is H, H, and H. There's this lone pair. And the dipoles are like this towards nitrogen and they don't cancel out. So that's incorrect. The H and H bond angle decreases when the ammonium is formed. Yeah, that's correct. Firstly, it increases. It does not decreases, it increases. Why it increases? Because look, initially there was a lone pair here which were pressing these more. Now there's a bond pair. Bond pair repels less. So the bond angle is gonna increase definitely. The hybridization of nitrogen does not change and there's electron transfer. No, there's no transfer. The C option is correct. So this means that this is definitely not gonna have a, the angle is definitely not gonna decrease. It's gonna increase. The hybridization of nitrogen does not change. That's correct. The hybridization of nitrogen does not change because what nitrogen is doing is not making a proper bond. It's just making a dative bond with the hydrogen. So the hybridization is not gonna change. So it's gonna remain sp. What's the hybridization? sp2. The hybridization of nitrogen because it's making 3 bonds. One is a dative bond. So the hybridization does not change when you are making a dative bond. So moving on to the next question, which says that nitrogen and carbon monoxide both have a MR of 28. That means they're isoelectronic. Are they isoelectronic? No. MR and electrons, they're different things. So the boiling point of nitrogen is 77 K and carbon monoxide is 82 K. Why is that? Because look, carbon monoxide is a polar molecule. Why is it polar? Because look, there's a permanent dipole towards oxygen. So I know molecules have a permanent dipole and N2 does not have a permanent dipole. Look, they have the same amount of van der Waals. How do I know it? Because count. Nitrogen has 14 plus 14. How many electrons nitrogen has? They're going to have approximately the same electrons. I don't care about the electrons because when you have permanent dipoles, definitely your melting boiling point is going to be higher. Permanent dipole. Okay, solid aluminum chloride sublimes at this temperature. Which structure best describes the species in the vapor at this temperature? Okay, so I have to show the dative bonding. It's not from aluminum to chloride, it's from chloride to aluminum. So that's very easy. It's going to be option A. And with that, we end today's video. I hope you like it and do subscribe and comment if you want a second part of me solving some more AS level chemistry stuff, and do recommend in the comments which video should I make more. Thank you.